Hi, this is lesson 12, where we will cover KVM virtualization on top of Red Hat Enterprise Linux. I will first explain how KVM is organized and all of the parts that are involved while managing KVM virtual machines. Once you have a good understanding of KVM, we'll talk about the two most common management utilities. First, we'll discuss Verse, which offers a convenient shell interface for managing virtual machines. That is followed by a sub-lesson about Virt Manager, the graphical utility for installing and managing virtual machines. At the end of the lesson, we'll summarize all you have learned in the end of lesson exercise. So before starting working with KVM virtualization, it's good to understand a little bit what is required on your server to make it a KVM virtualization host. This is not really information that you need for the exam, but it is good to understand anyway. For the exam focuses mostly on using KVM virtual machines. So let's see what is behind it. So the first requirement in order to use KVM virtualization is virtualization support on the CPU. You can find out if this is the case first by checking the BIOS, of course, and from a running Linux system you can use egrep on VMX or SVM in the /proc/CPU info file. If these features are listed in the proc CPU info file, then your CPU is capable of supporting virtualization support and your machine can offer KVM virtualization. So if your CPU can offer virtualization, the Linux kernel can load the KVM and the KVM Intel modules or the KVM AMD module if you are using an AMD CPU. On top of the Linux kernel there is libvirtd. This daemon allows you to manage KVM virtualization. Well, basically libvirtd doesn't only allow you to manage KVM virtualization, it can communicate with other kinds of virtualization as well, such as Linux containers and other virtualization techniques that we are not going to cover in this course. Now libvirtd is a generic interface to virtualization that can be used by different management programs. The most easy to use management program is Virt Manager. We will see that in this lesson. It's a graphical user interface that allows you to manage virtual machines in an easy way. There's also Verse, which is the virtualization shell. It is a shell interface that allows you to manage virtual machines in a scripted way. Very easy, very convenient if you have many virtual machines that you want to manage in an automated way. And then there's Virt Install, for example, which is an installation interface. It's just a small program that you need to install virtual machines, which, by the way, you can also do using Virt Manager. The interesting thing about libvirtd is that you can basically use anything you want. So in some environments it is custom to develop a custom-made program to manage virtual machines. Imagine a kiosk environment, for example. You could easily develop a program that allows you to start a virtual machine and to reboot a virtual machine and get access to the console and nothing else. And that is all provided by libvirtd. So libvirtd is a very essential part when working with KVM virtualization. So let me show you the topics that we have reviewed on the slide and see how they work on a real KVM host machine. So to start with, you need to find out if your CPU supports virtualization. So that would be the proc CPU info file. In this file you get information about your current CPUs, and what we are interested in is the flags line that we see here. So what you should look for is the VMX parameter. This is an Intel based CPU, and on Intel it should read VMX. If you don't have VMX on Intel or SVM if it's an AMD CPU, you cannot do virtualization. But this CPU is perfectly fine to do virtualization. Oh, and by the way, if you are running in a VMware virtual machine, you can configure VMware Workstation or VMware Fusion to offer virtualization support on the virtualized CPU. That is kind of cool. This is a virtualization platform that is running within a virtual machine. Can you imagine that? A virtual machine in a virtual machine? It's bad for performance, but it is cool that you can do it. And it allows you to practice this stuff if you are running from a virtual machine. So the next thing that you need is Linux kernel modules. So lsmod pipe grep kvm will show if the kernel modules are available. And we can see that there's the generic kvm module and there's the kvm Intel module that offers specific platform support. And the last part is that we need the libvirtd service. So to check that, we use systemctl status libvirtd, and that is showing me the libvirtd is enabled and it is active and it is offering services. So this machine is completely ready for virtualization support. And oh, what also can be interesting, let me do an IP link show. In IP link show, you can see that there's a specific network device as well, which is BR0, which is the virtual bridge. It's like an embedded switch that lives within the machine that you are using. And it's offering the capability for virtual machines to share the network connector that is physically present in this machine.
To support KVM, first you need a 64-bit kernel. So if you type ARC, you can see that the architecture of this platform is x86 64, so that's 64-bit, and that's good. Next thing you need is support on a CPU. On this system I have an Intel CPU, and you will be looking for the VMX flag. To find out if the CPU supports it, go to this proc CPU file and see if the VMX flag is listed here. If it is, you can use virtualization on your machine. Also, we need the libvirtd process to be available. Systemctl status on libvirtd is showing me if it is currently available. So apparently it is, and it is active as well. There we go. On libvirtd you can use multiple programs to manage virtualization. The first interface I want to show you is VIRS, which stands for Virtualization Shell. If I just type VIRS, I'm opening a virtualization shell in which I can type really many commands to manage virtual machines. Have a look at this. Let me do exit from here and let's just focus on some of the most important VIRS commands. I want to do VIRS list to show you everything that we've got. Now if you type VIRS list, you get an overview of all the virtual machines that are currently running. If you type VIRS list -- all, you get an overview of all the virtual machines that are currently existing. Now what exactly is the difference? Well, apparently we have a virtual machine with the name small that is currently running. Let me use the command VIRS destroy small. This sounds, by the way, worse than it is. It's like pulling the plug from the virtual machine. So it's not really destroyed here, it is just stopped immediately. Now if I type VIRS list again, I cannot see the virtual machine anymore, and if I type VIRS list -- all, I can see that it still exists, but it just has a state of shut off. If I want to start it again, I can use VIRS start followed by the name of the virtual machine, which is small in this case. And the domain small is started. And this is basically everything that you need to know from the VIRS interface. Now all the virtual machines that are created on a system, they have a configuration file that defines what exactly the virtual machine consists of. And there's networking as well. And I want to show you a little bit about both of them. So let's first go to the etc libvirt directory. As you remember, libvirt is the management interface. And in this management interface we can find a couple of subdirectories. Actually what we need is the QEMU layer. QEMU in fact is an emulator that is pretty old, but which has been adapted to be used in a KVM environment. So in the QEMU directory you can see configuration files for all of the virtual machines. and you can open them and just read the XML of the configuration files. The best way to edit it is from the Verse shell, because Verse is managing access to this configuration file. So instead of using Vim directly on it, let's do Verse edit small. The difference is that if you do Verse edit small, you are sure that nothing else is going to write to the same configuration file at the same time. So you can see the entire configuration of the virtual machine in here, like its name and its memory and the amount of CPUs and CPU features and, well, basically everything, including the source file as well. This virtual machine is using a disk image file, which is not the best possible performance, but if you want to create a virtual machine in an easy way, this is the way that you can do it. Just tell the installer that it should create an image file, which will be created in the var libvirt images directory. Something else that is important is networking. So let's type IP link show. And what we see here is that there's a virtual bridge as well. So the virtual bridge is like a network switch that is embedded in the host operating system. We are looking at the host operating system here. And to this virtual bridge we have two network cards that are connected. There's the ENO network card, which is my internal network card, which I'm using on the host operating system to get to the outside. And there is VNet. VNet represents the network card in the virtual machine. So the idea is that within the virtual machine there's an ETH0 network card, and this ETH0 network card on the host is represented by VNet0. And it is VNet0 that plugs in to the virtual bridge. And if you do an IP ADDR show, you can see how the address configuration is organized. So what we see here is that there's an ENO, which is the physical network card and which has an IP address. And this is the IP address that the host machine communicates with on its network. And there is vir BR0, which also has an IP address. In case you wonder why is that is because the virtual bridge is operating in a NAT mode. So it is doing network address translation, which allows all the virtual machines to get outside with a specific IP address. So within the virtual machines I will see a 192.168.122.1 IP address. And this should be the default router for all of those virtual machines. I will show you shortly how the virtual machines are organized. To manage a virtual machine, there is a virtual machine manager. You can start it by typing virt manager, if it is installed, of course. You can see all the virtual machines that are currently available. So I have two virtual machines that are both shut off. I can remove some virtual machines from here if I don't use them anymore, which is the case for my VM. So I'm deleting it and it tells me, hey, I've got some storage associated. Do you want to delete it as well? Yes, please. So let's delete it and don't bother me again because I know what I'm doing. So this is my current virtual machine and I can open it. There we go. It tells me that the guest is not running. So let's click the play button to run the guest virtual machine. While waiting for that, we can talk about the hardware interface. So this is the hardware interface from which you can easily add hardware features. You can get a performance overview, and this is more hardware like the amount of CPUs and the configuration of CPUs and CPU features. Now the CPU features are kind of cool because you will see there it is, the VMX feature, which is available as well. So within my virtual machine I can create other virtual machines, because if I switch on the VMX feature in my CPU, well, I can use this virtual machine as a KVM host. Isn't that cool? Then we have memory. We can see that the current allocation of the virtual machine is 536 and the maximum allocation is 1 gig. Now this is something that is really useful about KVM. Let's have a look and see if the machine is already available. Apparently it's not. Okay, we'll wait for that. So the current allocation is 536. Apparently it's having a hard time starting up, so let's just make that 1024. Apart from memory, there are other options as well. Actually, boot options contains a very useful one. Imagine that you want to start a virtual machine from the installation DVD to do some troubleshooting. You would click CD-ROM, move that up in the list, and next restart the virtual machine. That will give you any CD that is connected to your virtual machine actually, which allows you to do troubleshooting if your virtual machine fails to boot. I'm going to remove it here because I just want it to boot from hard disk. Also, you can click this option to make sure the virtual machine is started automatically when it boots. And there is more. Well, let's apply the changes first. Yes, I know I have to start it again to make the changes effective. And there we can see the hard disk configuration, the CD-ROM configuration, and there's network configuration as well. Now let's switch to the console of the virtual machine by clicking on this icon. There's one more thing that you need to be able to do from virt-manager, and that is get out of a virtual machine. Because imagine that on the exam you're working in a virtual machine and you don't know how to get out. Well, fortunately you can see it. It's noted here, press Ctrl L plus Alt L to release a pointer. So if I am in the virtual machine and I move my mouse, nothing is happening. But if on my keyboard I press the left Control and the left Alt, I can see mouse pointer and I'm out of the virtual machine. And this is basically everything that you need to know from an operating perspective from working with Virtual Machine Manager. Now let's have a quick look at installation as well. Installation from Virtual Machine Manager is relatively easy. Just click the Create a New Virtual Machine button and type a name, like my VM. Next you need to specify how you want to install. I'm just assuming that you don't have any installation server that is available, so let's do local installation media. That allows you to install from a disk that is physically present in the host machine or from an ISO. I copied an ISO over to the host machine, so I'm going to use that. It is relatively important to show the operating system and version that you are going to use, because based on that Virtual Machine Manager will use some optimized settings. So after selecting the OS type and version, click forward and select the amount of RAM you want to use. I put it on a limited amount of 512 megabytes. And then specify the size of the hard disk. And let's make that a 2 GB hard disk. That's big enough for a test virtual machine. And next, you can just click Finish and this will start the installation of the virtual machine. So the virtual machine window opens, and if I wait a little bit, the installation window will load. There we see the installation menu that is offered by the Red Hat Enterprise Linux 7 installation DVD. So let's click in there and select Install Red Hat Enterprise Linux 7, and it will load the kernel and start everything we need to install RHEL 7.
So it's time for the exercise. This is a relatively simple exercise where I just want you to review core skills that you need to have in order to work in virtual environments. So first I need you to install all KVM software packages on your server. You can do that using this command. Just type the command and it will work for you. Then I would like you to create a small virtual machine using virt-manager. Activate the virtual machine window. You don't have to wait for the installation to complete. Just get it started to the moment where your operating system CD boots and the Red Hat installer starts asking questions. And that's good enough. Don't waste too much time on installing a complete virtual machine. So once you have activated the virtual machine window, it is very important that you know how to release your mouse from the virtual machine window. So practice that. And then you can use the verse command to stop the virtual machine that you've just created. And that is all I want you to do in the exercise.
In the exercise you see already which packages you need to install. Once you've got them installed, you can start creating your virtual machine using Virt Manager. So to create a new virtual machine, let me first shut off this one. Shut down. You click here to start creating a new virtual machine. Let's call it new VM. You need to specify the installation media. The best choice here is to use local installation media. So that will be the ISO or the CD-ROM. So there you select either the physical CD that is connected to your host machine or the ISO image, which you should have copied before starting this. If you don't have the ISO image copied to your system already, you could use ddif equals dev sr0 of equals /root rel7.iso, for example. I'm not starting it here because I already have it, but this is the command that you need in order to make an ISO of your installation disk. So back to the Virtual Machine Manager. Don't forget to specify the operating system and then click Forward. Depending on the amount of hardware resources you have, specify an amount of RAM. It doesn't have to be that much. 256 works for an installation if you don't need to do anything graphical. Next you need to specify the disk. Make it small because for a test VM you don't need that much. And then you can click Finish, which will start the installation. There we go. Select Install the Red Hat Enterprise Linux 7 virtual machine. Now another question in the exercise is to activate the virtual machine window. I have just done it now. I'm not going to wait for this virtual machine to finish installation. So I'm in the virtual machine and the big question is, how do we release the mouse pointer from the virtual machine? Well, that will be left, Control and Alt. You see the mouse button appearing here. And next we can use the verse command to stop the virtual machine that we've just created. You know what? I'm not even going to wait for this virtual machine to finish installation. I'm going to stop it right now. So verse list -- all gives me all virtual machines. We can see that we have my VM and new VM running. I do a verse destroy of my VM and I do the same for new VM to stop both of them. I'm not going to need them anymore. Then I can get back to the Virtual Machine Manager and from there I can delete the virtual machines. Do you see that? New VM still appears to be running. Verse list -- all. Okay, let's try it again. Verse destroy new VM. If this doesn't work, by the way, then it is probably because it is in a very early stage where the kernel hasn't even been loading. I have seen this on some occasions before. You cannot destroy a virtual machine that hasn't completely loaded, but the problem is all fixed now. The virtual machine has been destroyed. So let's delete this as well to make sure some disk space is made available and I don't need a small machine anymore. So we can delete all of them. And that is what I wanted you to do in the exercise.
So in this lesson you have learned how to work with KVM virtual machines. I explained a little bit about the architecture that is used behind KVM and that makes your computer a successful KVM host. And following that we have talked about libvirt and the interfaces that you can use to work with virtual machines on your computer.